flock of endangered whooping cranes begins an incredible journey. They've come back from the brink of extinction and are learning to migrate south. But this time, they are led by man. This groundbreaking event is the result of decades of research and labor, and it won't be easy. Cranes, birds who inhabit 5 continents and whose ancestors date back to the time of the dinosaurs. Reminders of our Earth's past, they are symbols of longevity and peace. Storytellers and artists throughout history have found inspiration from this great bird. But today, they are at great risk.
Come on.
Dr. George Archibald is the co-founder of the International Crane Foundation and one of the world's leading authorities on crane biology.
Come on. Come on. Come on. Come on. Come on. Come on. Come on.
There are 15 species of cranes, and 11 of them are threatened. And it's because of human activities that they're threatened, predominantly from hunting in certain parts of the world and through loss of wetlands.
Of all the crane species, the majestic whooping crane is one of the most in danger. By the 1940s, habitat loss, power lines, and hunting had destroyed the whooping crane population, bringing the number of migrating birds down to only 15. But scientists and conservationists came together to save the whooping crane. Efforts began to preserve habitat, increase numbers, and bolster genetic diversity. The first step was to protect the only remaining wild flock of whoopers, who migrate from central Canada to their wintering grounds at the Aransas Wildlife Refuge in Texas. Thanks to years of conservation work, there are about 180 birds in the flock today.
The whooping crane has become a symbol of conservation. They were so rare about 60 years ago. They're still very rare, but they've slowly recovered. And if the whooping crane can recover, so can a lot of other things. So they give us hope in this sometimes depressing era of environmental deterioration.
But because of its limited genetic pool, and because it could be wiped out by a natural disaster, one wild flock of whoopers is not the solution. Since the 1960s, scientists have experimented with captive breeding, hoping to create new flocks, and the wild flock was the starting place. Eggs were collected from the wild birds to start a new captive flock at the U.S. Geological Survey's Patuxent Wildlife Research Center in Maryland. The birds raised here were the first to breed in captivity. In 1976, the U.S. Fish and Wildlife Service and the Canadian Wildlife Service attempted a bold experiment. Whooping crane eggs bred in captivity were placed in the nests of sandhill cranes, making the sandhills surrogate parents. But the whooping cranes in that population suffered an identity crisis and were unable to breed. Although the experiment did not succeed, it furthered the understanding of the whooping crane's sensitive identity and delicate breeding habits. Whoopers imprint on the first thing they see and learn their habits from that parental figure. Birds in captivity had difficulty breeding because they were imprinted on their human handlers. Dr. George Archibald made a one-man attempt to address this problem in a whooper named Tex.
Tex was a whooping crane that was raised in 1966 in an environment that was devoid of cranes, only humans. So she was imprinted on humans.
She did not pair, she did not lay any eggs. So I proposed that this bird needed the association with the human in order to come into breeding condition, and that I proposed she come to the Crane Foundation and I would work with her. Working with her means spending many hours every day out in the field with her. And I had a little shack that I stayed in where I could type and read books. And whenever she wanted me to interact, she would give a little call, like that, and I would go out and dance with her.
For the whooper, an important courtship ritual is the dance that invites another bird with its body language. The dancing actually stimulates the crane's hormones in preparation for mating. After months of working with George, Tex was finally ready. She was artificially inseminated and produced a fertile egg.
And we named him Gee Whiz, and he developed into a magnificent crane, and today is one of the good breeders here at the International Crane Foundation. Imprinting is a very serious concern when you're working with cranes. It's very important that the birds are imprinted on the right object. So the costume rearing developed by Rob Horwitz back in the 1980s is a fundamental part of the whole operation migration process this year, because we don't want birds to end up like Tex. It's impossible to breed them with other cranes, and of course impossible to put them in the wild. They just walk up to someone and get into trouble.
Costume rearing techniques transformed captive breeding, ensuring that chicks would not imprint on humans and their wildness would be maintained. Whooping crane chicks bred with this technique were transported to Florida to make a new wild flock.
Since 1993 in Florida, costume-reared and parent-reared birds have been released from the captive flocks. More than 200 birds have been released. About 75 birds have survived. Many pairs have formed. We're hoping that the non-migratory flock in Florida will be a success.
The success of the wild non-migratory flock in Florida leaves one important missing piece in the recovery efforts for whooping cranes. Unlike most migratory bird species, cranes don't have the instinct to migrate, but must be taught by their parents. How could a wild flock be created that knew how to migrate and could pass these skills on to their young? The answer comes from an unlikely source, Canadian sculptor and aviator Bill Lishman.
I built a little ultralight aircraft that flew at bird speed, and I'd take it up for morning flights just before breakfast to sort of clear the air. I would see birds flying and realize I could fly at bird speed. One day I was cruising along in the fall, and about 500 feet, and here was this field that was just black with birds, and I thought at first they were starlings or some such, and I throttled back and settled down to have a look at this big black field, and the whole field rose up and it was ducks. And then all of a sudden I was in this huge flight of ducks, maybe 1,000 birds. And we were cruising across the countryside. They couldn't outclimb me and I couldn't outclimb them, so we were kind of destined to be together there. And it was like being in a river of birds, and I could see my house and like on the bottom of the river and it was just such a wonderful experience. So that was my real first experience flying with these birds, and it was so wonderful. It put me in another element entirely, and I had to find some way of repeating that.
Bill's curiosity was sparked. He spent the next 3 years trying to raise a flock of geese that was conditioned to follow the aircraft.
I had a call from a fellow by the name of Dr. George Archibald from the International Crane Foundation, and decided on initially doing some research with Canada geese, because they're not endangered. So we started out with Canada geese, and it took a long time before we got to cranes, but the initial work was done with Canada geese. But at the end of 3 years, after 3 flocks, I had a flock of Canada geese that would fly in perfect formation with me, and I spent hours that year because it was such a wonderful thing to do.
Bill teamed up with aviator Joe Duff to perfect the technique. They formed Operation Migration and led a group of Canada geese from Ontario to Virginia.
From the start, we had in mind that we would use this technique to help an endangered species. And of course, the most endangered species in North America that this applies to is the whooping crane. Of course, the recovery team initially didn't think it was a great idea because everybody knows you don't mix birds and airplanes. That's just a big taboo. And we didn't have a lot of academic credibility back then. We weren't doctors or biologists even. We were artists. So it took a while to gain acceptance.
The whooping crane recovery team agreed that before any experiments could begin with whoopers, the non-endangered sandhill would make an ideal stand-in.
So in 1997, we tried our first migration with sandhill cranes. We led a small flock from Ontario all the way down to Virginia. And those birds survived the winter and made it back to Ontario the following spring, and it was a great success, except they weren't wild. They were too tame. They landed at schoolyards and golf courses and a number of inappropriate locations until they had to be pulled from the flyway. And of course, that concerned the recovery team. So the following year, we designed another study to see if we could apply the same techniques and teach the birds to follow the aircraft, return on their own, yet avoid humans, select proper habitat, and in essence be wild.
A partnership was formed with U.S. Fish and Wildlife and other organizations to put a migration route from Wisconsin to Florida to the test, and to assess protocols to maintain the bird's wildness. Again, the sandhill crane did the test run.
It's kind of like when you're making pancakes, you throw the first one away to clean out the pan. So we flew the route with a flock of sandhill cranes, and that was to make sure we had good landing spots, to make sure that all our protocols were in place, and that we could keep the birds wild and fly them this amazing distance of 1,250 miles across the middle of America. It's very hard to find wild spots, etc. Anyway, that was the whole idea, and it all worked.
Finally, after more than a decade of research and tests, the time has come to teach the endangered whooping crane how to migrate. In March of 2001, the flock of pioneer whooping crane chicks are chosen before they hatch. They're raised at the Patuxent Wildlife Research Center, where the costume rearing techniques intended to keep the birds wild begin at the very start. Biologist Dan Sprague is the primary parent figure for this flock of 10 whooping cranes.
And the purpose of the white bag is just to cover me up. It doesn't really have anything to do with being a bird. But the purpose of the puppet is really to keep the bird's attention. And this is what they focus on, and this is what they interact with. Just before they hatch is when imprinting process begins. You can hear a little peeping coming through the egg even though they haven't chipped their way out. That's when the adults begin to communicate with them. So they'll start to do a little purr, purr, purr sound to them, and that'll get the chick excited, and he'll start peeping louder, and he'll start scratching at the shell with his egg tooth, and eventually work his way out. But that's really when imprinting begins. So that's when we begin playing recordings of the engine sound from the ultralight, and also this digitally recorded crane call that they recognize as their parent. They're pretty helpless when they hatch. Normally, their parents will collect food for them. It's usually like a high-protein diet, insects and stuff, and bring it over to them, and they'll take it from the bill. So we take this puppet, and we get a little bit of food stuck on the bill and give it to them until they begin to eat on their own. And then you still have to kind of wiggle the puppet around in their food just to cue them to eat, and then they'll come over and chow down. But that creates this really strong bond with the puppet. So they're imprinted on the sounds that we're playing to them as well as the puppet itself. And that's when we begin taking them out with the airplane. They're hearing that sound that they're already imprinted on, and the puppet is extended down from the cockpit of the airplane, and they can come around and follow that puppet, and then the plane will pull up a little further, and they'll come catch up and get their treats, and pretty soon they'll just start following the airplane. And that's how the whole process begins, that incorporates the imprinting with the conditioning to follow the airplane.
We know we can't look like birds, we can't have feathers all over us, and so we just disguise the human form so that when the birds are released and they run into or encounter their first normally dressed human, there'll be nothing they're familiar with, and they'll hopefully avoid that. These birds are raised initially beside adult whooping cranes, so the adults act as a sexual imprint model. So these cranes know they're cranes. They're not confused that they're aircraft, and they're not confused that they're people in white bags. So that's an important factor in this study.
On July 10, 2001, right before the fledgling age of about 70 days, the 10 chicks are transported to Necedah Wildlife Refuge in Wisconsin. The Operation Migration team that will travel with them to Florida is already set up. Soon after arrival in Wisconsin, the birds receive a checkup. One bird's health deteriorates and it dies, the first setback for the team. A wing injury takes another bird out of the migration, leaving 8 birds to train at Necedah.
The reason we bring them out here before they fledge is because when they begin to fly, that's when they start to become really aware of the big environment around them. So that's where they perceive their natal area, and that's where they'll return to breed.
Once the chicks are old enough to move around, we introduce the real aircraft to them, and that's parked outside the aviary. We have the wing removed from it so it can be moved around like a little trike. And they get familiar with the sights, the sounds, and also the prop wash, the air that comes off the prop of that aircraft, so they're very familiar with it. On the aircraft we have a speaker system, and then we can broadcast digitally recorded adult crane calls, so the birds are familiar with that too.
A careful yet mysterious relationship is being formed between the birds and the aircraft.
There is a relationship between the birds and the aircraft, and it's really hard to define. Personally, I believe that they're imprinted on us and conditioned to follow the aircraft. I don't believe that you can imprint them on something as inanimate as an aircraft. It doesn't. It moves, but only when you move it. Who knows what they think or if they even reason it out. But you can imagine that if they look at another adult bird, or an adult bird that has a certain shape, then it opens its wings, and has a completely different shape. Well, maybe that's how they relate to it too. We have a certain shape on the ground, then we get into our wings and fly away. They definitely are attracted to it. They are attracted to the sound it makes. You can see them get excited when it starts. You can see them pay attention when it moves. They'll follow it. Even if you taxi slowly down the runway, they'll walk the full length of the runway with it. There's no question that they follow that aircraft. Now, whether they see the handler in it and follow the handler, or follow the aircraft, it's hard to answer that question.
As the days pass, the birds make incremental progress in their conditioning, strength, and endurance. By the shorter days of fall, they are stretching their abilities to 8-minute flights, a huge accomplishment, but nothing compared to the 2-hour flights they'll need to do on migration.
Training is every day based on weather. Every morning we fly in that golden hour first thing in the morning when it's very calm. And we start by just taxiing the birds up and down the runways. Their high-speed runs turns into kind of hops, and then big elongated steps. And at a given time, they'll just get airborne and follow us around, and then it's a matter of building their endurance. The first flights are maybe a couple of 100 yards. Then before we leave, we're generally into 40 minutes of flying with the birds. Then we leave on the migration.
By the first weeks in October, the birds are ready and the pressure is on. The migration must take place before winter hits Wisconsin. Weather is already becoming a problem as the late fall winds pick up and storm fronts come through the area.
I think right now we're standing right in the middle of the pre-migration jitters. For us, it's a big deal. We have 1,250 miles ahead of us. It's a long way to go, and it's a lot of responsibility.
I'll do the job. These come with wipers so you can clean your glasses as you go with it. Snowmobile technology.
Day after tomorrow is target departure date. Target date means that the crew and all the team will be ready, and then we just wait for weather. And we have so much to do to get organized to do this, and we're nervous. We're always nervous.
The antenna wire wrapped around here, and
Yeah.
and this wire wrapped around there, so I brought the antenna wire all around this way.
Right. Rather than having a stick and rudder, you have a control bar, which we use to control the aircraft with. So it flies a lot like a hang glider. If you wanted to go up, you push the bar out. If you want to come down, you pull it in. If you wanted to go that direction, you would shift the wing like this, and you would turn that way. So the thing flies very simply. And it makes for a nice aircraft because there's only one moving part in the entire airplane, which is that connector up here. So all the controls of this aircraft have one moving part only. Birds, when they fly in a certain order. There's a certain dominant structure to a chevron of geese or cranes or swans. And there's a dominant bird out front. And that bird is out front because he's the strongest and the most dominant. And as soon as he gets tired, the next bird will challenge him and take over the lead. So it's more like a bicycle race than this benevolent kind of cooperative thing. It's the way they stay together, but it's based on dominant structure. And occasionally a bird will try to challenge the aircraft. So that bird will put a burst of speed on and try